Good afternoon, everyone. Thank you so much for having me. This is my first time in Stockholm, and I'm having a lot of fun. You have an amazing city, and everyone at this conference looks absolutely beautiful. This is something I've mentioned before. You don't see that happening at a lot of tech conferences. So this is great. And today, we're going to have fun. So we're going to play this game, the doppelganger game. And for those of you who don't know what a doppelganger is, it's basically when you find someone that looks a lot like you, but you're not related to that person at all. So our goal for today is to see how we can build an application where you can submit a picture of yourself or a picture of someone else and compare it to someone from the 80s, to a character from the 80s. And here you can see that my colleague Berg looks 95% like Arnold Schwarzenegger. And then Sam, who's an amazing woman in the Angular community, she looks a lot like her mother. Surprise! Cool. As Katerina mentioned, my name is Simona Cotin, and I work as a cloud developer advocate. And as part of my role, I'm basically building a good developer, or hopefully a great developer experience in the cloud on Azure. And I'm focusing on JavaScript and on the web. So if you have any questions about Azure, or if you have any questions about Azure, or JavaScript or Angular, do make sure to reach out, either on Twitter or even in person after this session. I'm really happy to chat with all of you. Another cool part for today is that we're going to do kind of a Tech Talk 2018 bingo, where we're going to cover things like serverless and machine learning and AI. Angular is not really a buzzword, and I'm definitely not going to cover blockchain, but because it's so popular, I've just included there. So make sure to check all the boxes, and at the end of this presentation, I'm going to share stickers with the ones that you've looked at this. Cool, so first episode, machine learning. This is a poem that has been generated by actual AI. It has been fed thousands of unpublished romantic poems, and this is the actual result. So you can see things like, I can do it, I couldn't do it, there is no one else in the world, there is no one else in sight. One of the things that I've noticed with this poem is that it's actually quite negative. It doesn't give you a very good outlook on life. And I think that this comes back to what Chris was mentioning earlier, where actually AI and machine learning takes a lot of our bias. So yeah, I think we should be happier sometimes, maybe. Okay, one disclaimer about this talk is that I am not a machine learning expert, but I'm here to show how I managed to get started with machine learning without having to know all the statistics and all the mathematics behind it. So I'm going to make sure that everyone is on the same page. So I'm going to start with the machine learning definition, where basically what we're saying is that machine learning is a subset of artificial intelligence in the field of computer science that basically uses statistical techniques to give computers the ability to learn with data. That's very important, without being explicitly programmed. Or as one of my very dear colleagues, Paige Bailey, I recommend you follow her on Twitter or on LinkedIn, whichever is your best medium. She's an expert in data science, and what she says sometimes is, I predict the future with computers. So that's what machine learning allows us to do as well, predicting the future with computers. Okay, but if we think of machine learning versus traditional computing, in traditional computing, what we normally do is we give a set of instructions when we want to solve a problem, and based on the input and the output and the conditions that we have defined, we decide something. Whereas with machine learning, we no longer have that set of instruction. What we normally do is we have a statistical model that compares some of the features of the data that we have, and based on that, it can predict something like the future. And there's different types of machine learning. We have of learning. We have supervised learning, where we basically have a set of data, and what we do is we tag that data, so we tell the algorithm what to do and we define that data, and then based on that initial learning and that initial experience, then the machine learning algorithm will be able to predict future values. Another type of learning is unsupervised learning, where basically it's the computer's job or the algorithm's job to find out which are the communalities or which are the differences between the data that we have. And based on that, there's different algorithms that we might consider. There's classification algorithm, which allows us to classify things like, is this a daffodil or is this a rose? We also have regression, which allows us to analyze linear data or multiple data sets. And here we might look at stock data and predict if the Microsoft share will increase after the GitHub acquisition, for example. And then we also have clustering, where we're trying to group things together. And if you want to learn more about how you can decide types of algorithms and how you can decide which one to choose, on the Microsoft Docs, Microsoft Azure Machine Learning, we have this algorithm cheat sheet where you can see, based on the types of data that you have or the types of decisions that you want to make, you can choose what type of algorithm you want to use. But coming back to our application, let's make machine learning fun. Our case study is building a doppelganger app. And what we have here is we're going to use a machine learning algorithm that we don't really, we're not implementing it ourselves, and we don't really care. It's kind of opaque to us. But then we're going to create a data set that we're going to fit into that machine learning algorithm, and that's going to generate a model for us. And using that model, we can take new data and then predict results with that. So we can basically take maybe Berg's picture, and based on the 80s characters, we can define who he looks more similar like. And the goal is to train data that will match faces to 80s character. So in this case, I look 31%, I'm not sure if you can see it well, yeah, 31% like Back to the Future. So the first step is data ingestion and preparation, which means that I'll have to find a lot of characters and pictures with characters from the 80s and prepare that data, tag it, upload it on a platform, and yeah, perform all of this. The second step is training the model. So after a few iterations, I'm looking at the results of my data and my model, and then I'm iterating over that, redefining pictures and re-tagging them. And finally, when I'm happy with all the results there, I'm going to deploy my model so that it can be used in web applications or in mobile applications, whichever medium suits best. The tools that I'm going to use here are Azure Cognitive Services. Chris already mentioned that there's different types of frameworks that you could use when doing machine learning. And I think that one of the best things about Azure Cognitive Services is the fact that it allows us to call some APIs without having to have all the knowledge of a data scientist. And we can analyze things like do image processing, so that's the vision API. We can analyze language, we can analyze speech, search with the Bing Search API, and knowledge. So there's a lot of things there. And the particular service that I'm going to use is the Custom Vision Service, which is a tool for building custom image classifiers. And this is going to help us be very fast. So let's go ahead and have a look at the demo. Let's see what it takes to build this application. And I already have in my browser here the Custom Vision API dashboard, where you can see some of the past projects that I've created. So I can go ahead and create a new project. But before doing that, I just want to make sure, has anyone here seen this dashboard before? Awesome. So all of you are going to leave today with something new from this session. Okay, so do we have a new name for this project? Anyone? TechWorld. Okay, Let's spell that correct. And then description, basically, I can just maybe define something that's very specific for this project. And the next thing that we need to define is the domain of our application. So the more specific we are, the better the algorithm is going to perform. One thing that I want to mention is that with custom vision service, so Microsoft has used all the data that it has available. It has trained a model for us, and we can build on top of that. So now, reusing that data and adding new characteristics to that data, we can reuse some of the work that has been done for us. By choosing food, for example, the algorithm will perform so much better with food pictures. Unfortunately, there's no 80s character category in this list, so I'm just going to go with general, and then I can create a new project. And this is going to take me to a dashboard where I can already upload pictures and tag them so that I can then test them against new data. So this is manual. This is very, I can click the Add Images button, and then I already have a few pictures in my local. So the first one will be Leia. And it uploads my pictures into the cloud, and then I have to tag it, so I have to give it a name so that it can be reused later on. And I'm uploading these pictures. So this can take maybe a few seconds or minutes, depending on the amount of data that you're uploading and the internet speed. But as you can see, this was actually very fast. Congrats for that. Public internet is not always that good. Okay, and then let's upload Luke Skywalker and tag it. One of the requirements here is that in order to be able to train a new model, we have to have at least 5 pictures, and we have to have at least 2 tags. So now I can go ahead and click train. And what this will give me, it will give me a new model that I can test against, and it will give me some data, some performance data about this model. And cool things here is that you can, every training session that you run, it's going to be saved as an iteration. And we can already see here, based on the pictures that I've submitted, we have 2 metrics. We have precision and recall. And precision refers basically to of the pictures that have been classified as Leia, how many of them were actually Leia. And then recall is basically of the picture that we have defined, we have tagged as being Luke or Leia, how many have actually been recognized. And it's important to have both these metrics, because you can imagine where you have very extreme use cases where the algorithm has very, very good precision. It recognizes all the positive cases, but then it doesn't actually do recall very well, which is the case for Luke. So chances are that Luke won't be we won't have very good data for Luke. So I can go ahead from here and run a quick test. And I've asked permission from Chris to use one of his pictures. And we can see from the algorithm that Chris looks 23% like Leia and 11% like Luke. As you might imagine, these are not great results. Ideally, we want to have at least 90% probability to be certain that this data is correct and that the model is working correctly. I don't think Chris looks a lot like Leia, but probably because he has longer hair, the algorithm has decided that this is the best match. One of the, and this is where adding more data and training and tagging correctly comes into place, and having correct data. One of the things that I've noticed is because we are looking at pictures from the 80s, the quality of the pictures is not great, so then the data is not going to look fantastic. Obviously, Leia looks Leia was doing much better. In the case of Luke, only 2 of the pictures were classified correctly. The other ones, we can see that it's 1.3% Luke, so the algorithm doesn't really know what to do. Ideally, from here, we want to upload more data and use more pictures and tag them correctly. So we've seen how we train with images, how we evaluate performance, and then how we can run quick tests. Another thing that I wanted to show you is here we also have a prediction API. So instead of running the tests in this dashboard, you can actually integrate this service within your application. And that means a web application or a mobile application where you can just call a URL, send an API key, as you can see here, and then, please don't copy this. And then you just send the picture or a URL to the picture, to the actual picture. And from this, one of the things that you might think is, if we have to upload thousands of pictures, doing this manually, how does that feel? Would you enjoy doing that? Would that be a good option? Probably not, right? You wouldn't want to be doing this manually. So this is where another topic that I'm super passionate about comes into place, and that is automation and serverless. But before, let's define the list of tasks that we have. So what did we do? We had some pictures that we wanted to tag with different names, and then we wanted to train our model once we've uploaded those pictures. So these are the 2 tasks that we have. And getting a list of what we need to do, because we've seen that we can actually upload URLs, the first task that we have is getting a list of URLs for different images. And we kind of know where this is going, probably. I'm sure Chris knows. What we can use to get a list of URLs is the Bing Search API. So we can query for a certain word, and then the Bing Search API will return us a JSON with a list of results that includes a URL for a certain picture as well. So you can see here all the data that Bing Search API is returning. And this is just a request. Like I can test it with Postman. It's a post request where I can send different parameters. And then the second API that we need to use is the training API. That moment when I clicked the train button, I can actually just upload pictures to the custom vision API and train that model. And I need to, one thing that I need for that is a tag. That you can see there. Okay, so next episode is serverless. How many of you are familiar with the concept of serverless? There's a few hands here. I'm happy to hear that. So I'm guessing that you already know that serverless doesn't mean that there are no servers. It just means that we don't have to babysit servers. And when we're writing serverless applications, we're basically mostly depending on third-party APIs, as well as writing custom code that's specific to our application. So in this case, you can imagine that the Bing Search API is a third-party API that I'm using in my application, and then I'm going to write some code that will actually call that API, and that's the custom code. And when we're writing serverless code, we're basically writing code that reacts to events, and there's different types of events that we can listen to, like HTTP requests, that's a type of event. File that has been uploaded in a storage account, that's a type of event that we can listen to in a serverless environment. Another thing that's important with serverless is that it auto-scales. So we don't have to worry about servers, and we don't have to worry about managing them so that they kind of listen to, they auto-scale, and we don't have to manage any of that. And then the other thing that's important is that we pay as we go. So with serverless, we only pay for the amount of CPU cycle and memory that our code is using while it's running. So you can imagine that your code is hosted in a storage account, and whenever an event comes in, our code is going to be deployed in a container or in a virtual machine. It's going to run. It's going to do its things. If we only have one request, then it's going to be only one instance. If we have 1 million requests, then the cloud provider will make sure that all the instances required to serve all those number of users are going to be deployed, and then we only pay for that CPU and for that memory. So that's great. But coming back to our tasks, that was just a quick overview of how serverless works. If you have any questions after that, we can definitely chat. But coming back to our tasks, what we need to do is retrieve a list of URLs and then submit that to our training API. So those are two separate functions, and the reason for which those are two separate functions is that we want to be able to scale those, and we cannot control how long it will take. Like if we retrieve 1,000 URLs and then we have to submit them, or we're not sure. We want to make sure that we can parallelize those tasks. And the smaller your functions are in a serverless environment, the better it is. So this is our goal. The way we're going to implement this is how we actually define a function in a serverless environment, and this is JavaScript. We basically use a binding from Azure Functions that allows us to bind to write to a queue. And then the other thing that we're doing is basically make a request to the Cognitive Services API, to the Bing Search API, where we're sending a message, we're sending a query, and then we are asking for photos. And then the next thing that we want to do, the other function, is where we're making a request to the Custom Vision API to train our model to take those new pictures. So here you can see that we're using a training key, which is defined in our process environment variables. All is really cool. And we're sending a tag ID and the list of URLs. So we've achieved this. My code is available on GitHub, so you can definitely check it out after that. And finally, this is how we can actually call that prediction endpoint, where you can get the results. So this is, again, a function in Azure Functions. And you can see here that we're making a request where we're sending to the URL that's defined on line 10. And we're sending API key, and then the image that we want to test. And we're going to receive a response with a list of predictions for that particular tag. I'm making a lot of assumptions here, like my colleague Chris pointed out. I didn't test this. I tested only the happy path. I should add more exceptions there. But after training our algorithm with more images, we can see that Chris looks 97% like Arnold Schwarzenegger. I hope is that happier? Is that better? You like Liam Moore, right? I like Liam Moore too. And if you want to try this yourself, you can find the application running at aka.ms/80. So you can submit pictures of yourself and just get results with who do you look more like. Some of the resources that you might be interested in. The first two links are links to my GitHub repositories with the projects the code that I wrote. And then if you're interested in learning more about Azure Functions or the Custom Vision service, you can use those links as well. Thank you very much. I hope you enjoyed this.
Thank you. This was really showing that machine learning could really be fun.
Yeah.
We're all going to load up our picture there to check which 80 stars we look like, right? We don't have any time for questions right now, but you will be around.
Definitely.
So you can have your questions directly to Simona.
Yeah, that
Thank
sounds
you
good.
so much. Thank you.
Thank you.